Hello everyone, welcome back. So yesterday we designed a couple of systems and we made significant progress in our understanding about how to go about system design and uh, during an interview and how to structure our answer during the interview. I mean, it doesn't have to be just interview specific. Even when we are thinking of designing a system from scratch, we can follow the same approach or same mental model while thinking about high level design and then going in deep to the specific components of the system and then making it more reliable and making it more performant by fine tuning certain things and adding certain components. Yeah, that it's a good thought workout, or it's a good exercise for us. So today we are back. We want to design a new system uh, for system design. Like we can start with the system designing the YouTube. Today, I'm not using that open source GitHub repository. I'll be using some other materials because looked into the GitHub repository that we were using. The rest of the design follows kind of similar patterns. I check this out, and rest of the design has a lot of repetitive comments. And also, if I open any of those, designing a social network or anything, it gives us the same diagram, just the service name would be different, and then all the scaling approach and everything would look very similar. But yeah, we can get back to this if we have time, but we have to make the best use of our time now. So let's diverse ourselves a little into using some other materials. So let's dive into the system design of YouTube for now. I'll be using the whiteboard and the notes that I was creating like yesterday. So let's add another page here. Okay, design YouTube, and I got to make it as a page. Okay, so now let's navigate there and we can manage our notes here. I hope I'm sharing the right screen. No. So let me share the screen. So designing the YouTube. So welcome to today's stream of designing YouTube. So let me let me see what materials I can refer and how can we start with the approach. So first thing, as we saw, YouTube is a popular video streaming service where users can upload, stream, and search and comment and share and like or dislike videos. So uh, we are all familiar about the functionalities of YouTube because that's where we are consuming this video as of now, and I'm creating the video as of now. So large businesses as well as the individuals maintain the channels where they host their videos, and YouTube allows free hosting of video content to be shared with users globally. YouTube is considered as a primary source of entertainment, especially among a lot of demographies. And it's the second most viewed website after Google. So that says something about YouTube. Let's see. Let's see. Let's gather some requirements. So as we know, like we have been dividing the requirements into two broader categories: functional and non-functional requirements. Functional. Let's dive into the functional requirements first, and then we can address the non-functional requirements. Okay, for functional requirements, users should be able to uh, upload videos, users should be able to stream videos, and users should be able to search videos based on certain keywords, and users should be able to like and dislike videos and interact with the videos as well. So let's see, how can we list the user should be able to upload videos. User should be able to stream videos, and then user should be able to like or dislike or comment on videos, and users should be able to, okay, this is getting out of hand. User should be able to upload videos. Okay, let's take the common thing out of this. Okay, if there's some operations that is not from the user, then we can talk about it later. I feel formatting these inputs and everything in the interview, that would also create an impression. We should make the information as easy as possible to the interviewer. We should try to keep their attention on our design or on our explanation throughout the process. So it's it's important to arrange our data or arrange our writings in the interview as neatly as possible. So let's see, like and dislike the videos, and what else we can think of. And then search. Users should be able to search the videos based on keywords. I think this should be good enough for now. And as a non-functional requirements, I think we care about the availability of the videos. So the system should be highly available, and scalability wise, as the number of users grow, the issues should not become the scalability issues should not become a problem later in the future. So let me see. And what is reliability in this case? In this case, reliability means the uploaded content should not be lost or damaged. So the storage should be reliable. And then performance means a smooth streaming experience leads to a better performance overall. So the performance goal in terms of streaming, or in terms of streaming the videos, and also reliability in terms of saving the data, and scalability in terms of scaling it as the number of users grow, and availability, it's self-explanatory. The website should be available and should have a good uptime. So let's write it down as well. So we care about availability. Do we care about consistency in this case? For example, if we have, like if we feel like we just don't have to throw in the terms here just for the sake of it, why availability, why not consistency in this case? If someone's in the stream, feel free to comment about it. We care about reliability, and also we care about okay, availability, scalability, reliability, and yeah, these are kind of good points that we can go with as of now. Availability means uptime, and scalability should handle the user growth without any problems. And reliability is the content uploaded should not be damaged, or lost. Okay, so let's go with these requirements for now. What else can we think of now? Yeah, so I asked the question, why just, let me post the notes as well. Let me post the notes to the ones following if you want to follow along. Okay, and yeah, why not mentioning consistency here? Why availability? Because I don't think when in the YouTube channels we care about making the video available across the entire user base at the same time, as opposed to keeping the website available. What I mean to say is, it doesn't matter if all the users on the platform see a consistent view or see the same view of any channel or anything. But it's important if we are rendering the channel, like, yeah, let's say if two users tries to uh, access the channel, Beast's channel, and then if one of them sees the video which was just uploaded, like, within milliseconds ago, and if the other user doesn't see it, it's not a big issue. As opposed to, like, if one of the user who is not seeing the most recent version of the channel, if he is having downtime just for the reason that, okay, he is not able to see the most recent version, that's not acceptable. So most important thing is being available, and then eventual consistency is acceptable. So yeah, let's move on to the next phase. So next phase can be, let me look into this. Let me take time to read and then come up with that. I don't want to read it as it is from certain materials or things like that. And I want to aggregate it from different platforms and provide a holistic view here. Okay, we can represent this one as, let's see, we can view the system as something like how to represent the, okay, let's just write it as client. Client would be communicating with the server as a basic as it can get. Okay. And then the server would call something like a encoder or transcoders. How to represent this? This wouldn't provide anything else. So okay, and once that is done, we will have to store the metadata of the video or metadata of the content in certain database. So that one we can represent as something like this. Yeah, this looks like a database. Okay, DB, and the server has to connect to the DB. Okay, and what is stored here? Data and metadata and content metadata. User data, it's kind of common, but yeah, here the significant thing is content metadata. And then once the content is sent to that encoder or transcoder, that would generate the video in different formats and try to present it to the blob storage. So blob storage or we can represent it as like object storage, like S3 or Google Cloud Store or something like that. Okay, so here the encoder or transcoder should convert it into different formats or different formats to support varying device types. Yeah, so that should be good. And then how it is served to the client again. If the client wants to watch a certain video, then it will be mostly connecting with a static caching layer like a CDN. Let's represent CDN this way. CDN is content delivery network. So basically, what's the use of content delivery network? So the user could have directly connected to the server and access the data, or it could have directly queried from the or directly looked it up from the object store like S3. The benefit of adding CDN layer in between is CDNs usually serve the data from the closest geographical location. So fetch videos. So this remains in closest geographic location. So that would reduce the uh, latency as well. So if we want to connect to the nearby servers, like let's say if we have the data hosted in a data center which is in Europe or somewhere, and if the person lives in LA, if there is a CDN that is located in uh, San Francisco, so it's much more closer and it's easier to query the data from there with less latency. So that's the benefit of having a CDN layer in between the object store. So and how the CDN gets the data. There are a couple of different types of strategies like pull-based model and push-based model. So usually the popular one is whenever the first user request comes asking for a specific type of resource or a specific resource, it checks if the resource is already cached in the CDN layer. If it is cached, then it will just return that, or else it will query from the object store or the backend server, and then um, stores it upon first access in the CDN cache, and then returns it directly in the subsequent requests. So that makes it easier. So yeah, that's the high level design that we can think of. So let me get it to our nodes. So this is like a okay, high level design. Okay, so Excalidraw. It's hard to copy from there directly. So what should I do? I can okay, that works. Yeah, I'm just trying to move it to the left. So okay, so here let's explain as much as possible about each of those layers. So how the data flow works. First, the user will upload the video to the server, and then the server stores the metadata in the DB and then sends the actual content of the video to the encoder or transcoder. The encoder or transcoder would work on converting, like it will compress and convert the data into multiple different formats because the resolution that is required for different device types and different screen sizes are different. So it will convert it into all the supported formats and then stores it in the object store. Once that is done, the client would either request the closest geographic location CDN in order to render the data. If that doesn't contain if doesn't have the cached version of the content, then it will query from the object store and it will cache it for the subsequent requests. So I think that is good enough high level design. Let's get to let's write that or mention that in our notes as well. Okay, so step 1 is user makes the request to the server, or user uploads the content. Users make upload request, okay, to the server. And then the second step, server stores the metadata in the database. And step 3, server forwards the video, or it could be image content, to the encoder transcoder. Let's look into the encoder or transcoder in detail sometime later. I too do not have enough information about how that particular part works. Encoder or transcoder. I just know the purpose of that layer. Encoder or transcoder compresses and converts the content into different supported formats. And supported formats in order to support different device styles. Okay, and once that is converted, all the converted content format are saved in an object store, so such as AWS S3. And then when the client requests to view the content, then it will send the request to the CDN. CDN will respond quickly if it has the cached version of the content. Else lookup from the query is not the right word, since it's not the relational database. I would mention it, else it will look up from the object store and caches it for the subsequent requests. Yeah, this should work. Okay, this is good enough high level design. Let's capture these things here. So now let's go back to our functional requirements and see if these components can address all the functional requirements that we derived before. So in the functional requirements, there was a requirement to upload videos. Yes, we can support the upload workflow with these components. Upload will make a request to the server, and then encoder will convert it into different formats and stores it in the object store, and also stores the metadata about the content in a database. Stream videos also, it should follow the same format, but let me read about the streaming videos as well, if there are any unknown challenges while streaming the data that we need to consider. and then like and dislike and comments. These are like any other metadata about the video. We should define different tables in the database, and then we should store that in the database tables, and search the video based on the keywords. So yeah, we can define different services or finer services within the server layer. But yeah, that should be handled by client, server, and database. Like, it will look up the database where the content is stored, and then once it knows the links or the URLs of the content, it can respond to the client, and the client would res- client would look up those content by fetching the videos from the CDN. So those things can be addressed. So functional requirements are addressed. So next thing is, we should look into the detailed design components, how we can improve this overall design or the high level design. So that can be done by few more things. Let me see. Let me take some take some time to read about it and think about it, and then I'll get back. If someone's following me along the journey, feel free to design it as you would have approached it. Uh, until I'm studying, as long as I'm studying, and also feel free to post any questions that you have in the comments. I would make sure to address that, or I would make sure to talk about it. For anybody who joined now, I'm running this stream in the format that, okay, I'll read about a section, or read about a topic, and then I'll try to summarize it in my notes by giving appropriate explanation, by breaking it to easily consumable format. So let me know if you have any questions, or if you did not understand anything that I have spoken about in the past here. I'm happy to elaborate. Okay, I looked into this problem. I think our early intuition about the high level design was good, but there are few things that we can address in the detailed design. But before doing that, let's get to the API and the data model things that we are going to address. So APIs, for APIs we have upload video And for upload video, so that could be something like if we are using Rest, then it would be like post videos slash some ID, post videos, I guess. There won't be any ID, and then the parameters or the data that we pass are uh, like something like the API key and things. Those things are common. Other than that, there will be a video title, and like there can be a description and tags, and also um, the channel or something if it is not YouTube. If it is something like other streaming service like Netflix or things like that, uh, I think we can have a locale or language information, locale information, and also the most important thing, the video content. So this can be one of the thing to upload the video. User should be okay, upload the video, and then search videos, that can be another one. So use case would be to search videos. So when the user want to search videos, the API that they would use is get slash videos. So there will be corresponding algorithms used for search. I think we can just pass certain keywords, something like keyword is equal to search keyword. It could be using the title or the searching from the description, or could be anything there. And then the response should be it should return the list of it should return a list of videos with the above attributes. Like each individual video should have this attributes. Yeah, so that should be a list. And yeah, and then what could be the next use case? The next use case that we need to address is that like, share, and comment, and all those things. So all those things can be handled basically like interactions with the video or user interactions with the video, like like comment, like, dislike, or comments. Okay, that's what I can think as of now. So for these things, we can do it like post videos, and then there should be a video ID on which the user is liking or commenting, and then interaction, or we can just make it as video ID. Okay, so what can we do here? And also, is post is appropriate when we are like it is on the video resource, but it is a comment. So let's make it as comment, and it should have comment like actual text, and then the comment can be the response to some other comment as well. So that can be parent comment ID. Yeah, and the time is required, timestamp. Yeah, I think these are the things that I can think of on top of my mind. Let me know if I have missed anything. Feel free to comment in this live stream. It's kind of like we are going round and round, like Meta world. We are designing YouTube on a YouTube live stream. That's cool. Okay, so these use cases are good enough. Now let's get into the database schemas. So database schemas can be like first thing is we need to store the video metadata um, in a SQL. Like let's assume we are using SQL database in order to store the video metadata, and we will use a file storage or a object storage to store the actual content. I mean the video and the thumbnail and other things which are needed. So for video metadata, let's see the schema that we will be using. So this should contain a video ID and then title and description. Okay, I know all this on fresh up on in my memory as fresh memory because I while creating the stream I need to enter all those details, um, and then like thumbnail, and thumbnail would be like URL of the file storage or the object storage for that thumbnail, and we can have the user or uploader and number of likes. These are like computed values. These will be computed values. It won't be provided when user is uploading the video, but these will be the metadata that would be stored uh, uh, later on. So number of dislikes and number of views. Comments can be stored in another table and have a foreign key relationship with this table. So let's see how the comments can be stored. We can have a separate table for that, for comments. So okay, so everything starts with an identifier in a database. So comment corresponding to which video. So we will store the video ID in relationship with the above table. And then the user ID. This is not the user who created the video, but the user who is commenting. And then the actual comment, which is a text. Let's capture it as text. Yeah, or the comment is also fine. And then timestamp of the comment. So this should be good. These details are good enough. And then the obvious user storage and all those things would be there. So let's capture these as heading 2, and this one also can be a heading. Okay, so this looks good, all this looks good. So next thing is we have a high level design. We have the use cases that are being supported using the database schema and the APIs. But the next thing is we need to also think about performance improvements or the scaling aspects of it. So let's see how we can address that. So design deep dive. So in this one, like, okay, let's see what all bottlenecks do we have here in our original design. Let me open that whiteboard where I had the okay, we had this basic version. So in this one, what all bottlenecks are there? So the server. So server itself, if we have a single server serving the requests of all the clients, that would be a bottleneck. I mean, it's kind of implicit, but I will try to add it. Let me modify this thing here. I'll try to add the components as and when we can think of here. Let me add a load balancer. So load balancer in between here. Okay, so this one should go here, and the requests are made via load balancer. Okay, so now we have added a load balancer layer. And another thing is this one. This is kind of uh, making me a bit uncomfortable here, because the transcoder and encoding and transcoding job can take a long time depending on the uh, content size or the video size. Even then, we have just captured it like the server will contact it like a synchronous request. That's never gonna work. So let's modify that part and try to add some message processing queue, uh, and add the content there, and then we can, and then the transcoder can pick up the job from that queue and then try to transcode that video. Before that, the server can respond to the user with the 202 that okay, your request has been received and we will work on it. So how to represent a queue? Let's see. Yeah, I think this looks like a queue, I guess. Yeah. Okay. And yeah, we can modify this one like this way. Yeah, now we have the queue, so that serves the purpose. The database, let's see, we have captured it very simplistically. This is a metadata DB. Let's assume classify the database into two categories, metadata DB, and the other thing can be something like a user database, user DB, and okay, we don't have to represent this. Okay, this is fine. And why I made this changes basically for the DB. Once the transcoding or the encoding is done, we need to um, store the information in the metadata as well. So metadata as DB as well. So the encoder should update the metadata DB. So let's add that link to make it more explicit here. Okay, so that looks good. Once that is done, we have, and also another thing is we need a caching layer. So for videos, like let's say we have added a CDN. As I mentioned, CDN can store the geographically appropriate or most popular videos in that geographic location as well. But do we need any other caching layer for the metadata and everything for the most popular videos or most searched videos? Maybe, but how to think about it? Um, so this database as well, do we need to share it into multiple replicas, um, or things like that? Let's see. Okay, okay, it was looking better before. Okay. And I get stuck like this sometimes in the interview as well with these tools. That's the most painful part. Okay, this is good enough. Okay, and this one becomes user database. Okay, we need to share it, but the challenge is on what parameters do we share the database. We need to address those things. So what all things we have been adding? So we have been adding transcoding or encoding and transcoding. Okay, let's assume it as add a queue before sending the videos or content for encoding or transcoding layer, because that could be resource intensive job and time taking. So it's better to have a queue in order to have regulated traffic into that layer. And then we need to think about the load balancer that we have added. Load balancer in front of the web server to distribute the traffic between different instances. Okay. Next thing is we know the CDN. CDN, like here I'm kind of interchangeably using the CDN and the caching layer, because the like whenever I say caching in this context, the more I can think about it, we need caching for the static content like the video or the thumbnails and things like that more often than actually metadata. We might need the caching for the metadata layer as well, so we can add something like Redis or memcache in between the server and the database layer. But here, whenever I'm mentioning caching, um, caching static data here. Whenever I'm mentioning caching, it's more like for the content or the video. I mean, for the video or thumbnail, can cache the video or thumbnail more closer to the user location, and helps improve the performance. Okay, and also another thing is, yeah, like I mentioned about sharding. So for to scale the database, how can we handle it? Database, we can think about sharding, but what would be the strategy? That's the most challenging part. So sharding based on user ID, if we do that, or user, if we do that, then that can have like if a particular user goes viral, then that can have an imbalance, can create an imbalance and direct all the traffic to one of the instances uh, when the user gets more popular. Imbalance in traffic pattern, traffic to that instance if the user gets popular, and we would need to reallocate or reassign the user to a different shard. So that is painful. What if sharding based on the video ID? So that the same problem exists. Instead of user, if the same problem as above exists, if the individual video becomes popular, then that server would be flooded with a lot of requests. So what can we do? So it is it is better to store or cache the viral or the hot videos and reduce the burden on the database servers. So yeah, even if there is a cache miss, then only we will go to the database to query. And these data, we do not, as we discussed in the beginning, we do not care about the consistency. Like if two users are seeing like little delayed version of the same video or little outdated, it will be eventually consistent, and we do not care about having a consistent view. So it's okay to cache those static data. It is a good experience. So yeah, we spoke about the load balancer, we spoke about the queue layer before the encoder or transcoder, and then we spoke about the CDN and how it helps and how can we scale the database as well. This should work, but yeah, but the user are in an actual interview, it doesn't work this way. The interviewer will have some specific question that we need to answer, or that we need to talk about. So it's good to have detailed information on all these layers. So if we are addressing or if we are talking about this design for over an hour or two in this practice, it's better. It will give the condensed view when the user asks or tries to dive deep about a particular layer during the interviews. So I think this should be good enough. Let me know if I have missed any particular thing of interest here. Um, Metadata sharding and also video deduplication. That's another thing that we can talk about. Like I saw it in one of the materials. Video deduplication can basically reduce the storage or make the storage efficient. So video deduplication means identify if the user is uploading an already existing video based on using certain algorithms. I'm not very familiar with those algorithms, like there is a matching algorithm or matching patterns or things like that. Using matching patterns. Okay, so how is that useful? If we identify that, then we can make our storage efficient and improve user experience by avoiding the recommendations with duplicate videos. I mean, it doesn't matter if we provide the recommendation for similar type of videos. So yeah, that way we can make the most use of it. So when I say storage efficient, both in database layer as well as the caching. So yeah, that is a huge impact. And then how the caching is very useful is so here I like this quote. The 80% of the traffic to the servers come from the top 20% of the content. So if we keep this in mind, caching plays an important role. So it's easier to cache the selected items there. role when we know that only a fraction or only a part of the content is viewed more often. Okay, so these things plays a role. Let's make it as a heading as well. Okay, I think, yeah, I think it gives a holistic view of the system. We can talk about the specifics, but yeah, I can think of only these as of now. Let me know in the comments, like if I have missed anything obvious, and if you want me to talk about those things in the future videos. Uh, yeah, as usual, I'll get back with another design in the evening, or probably to switch things up. I might come back with some coding problems. Let's see. Yeah, stay curious and keep learning. Have a good one.